shifting into learning more about the nail itself is derived from the stratum corneum. So we're looking at those keratinocytes, the dead, flattened keratinocytes. That's actually what your nails are made up of. Now you're thinking, hold on, your nails are harder, they're different. True, because as your nails are made, those same cells are compressed even more than in your skin, and therefore they create a harder substance. So really they're just simply thin, scaly cells, completely dead, because that's why it doesn't hurt when you cut your nails. But they create this harder structure because of how much they're compressed. Plus, they're filled with more actual fibers and more keratin, making them harder and more durable. So the nails themselves, same material as the skin, just processed in a different way. So to start with some different terms. Nail bed. Now the nail bed itself is the skin that the nail rests on. So you're looking at this area right in there. That's going to be the nail bed, just the skin underneath the nail. You then have the hyponychium. The hyponychium is going to be right where the actual finger meets the nail bed. So that's the hyponychium right there. That's that part of the actual skin that's kind of almost joined to the nail. And especially if the ever gets separated, you definitely know it because that can feel horrible at different times. So the hyponychium. The free edge. That's simply where the nail grows past the finger's edge. So this is the free edge of the nail. It's the part that's beyond the actual skin itself. You then have the nail body. The nail body is just the actual nail itself. It's the part that runs over the skin, the nail body. So when you're looking at the nail, the majority of it is going to be the nail body. Nail root. The nail root is this part that's back there underneath the fold of skin. So the nail root is not visible as long as everything's attached normally. But you can know it's there because if you ever happen to damage or drop something on your finger just beyond your fingernail, but then weeks or months later, also you notice, there's a black patch or red patch growing out of my nail. That was when you actually caused damage to the actual nail root. And then you have the nail matrix. The nail matrix is where the new cells are added. That's going to be right back in here, right at the very start of the nail root. So the only place that you'll have cells being added into the nail is right at that nail matrix, the very beginning of the nail root. And then slowly, as you add more and more cells in, it grows out to form the nail. Nail folds. So nail folds are around the edge of it. So you have nail folds around the outsides. It's the edge of the nail, right where the skin is overlapping the nail folds. The eponychium is your cuticle. That's just right up here. The eponychium. It's the part that is covering or kind of over where you actually have the nail folds. So we have the actual nail star, the nail matrix. Then you have basically all that dead epidermis covering it on the proximal end, which also leads into the lanula. The lanula is this dome-shaped covering. So put this all in perspective. You start with the eponychium, which is right here. All the dead epidermis that's kind of overlapping. That's covering up the actual nail matrix. From there, though, then you get the lanula right in front of it. That's the coloration of it. So you're looking at the actual structural parts of the nail there. That pale crescent color, though, can actually be useful as a quick identification of blood flow into the finger. Because if you press on that, it'll change colors. But then, depending on how fast the color goes back to normal, can help to differentiate, is there normal flow or something not quite normal in this case? But the key is normal for each person. There's not one clear cut, it's this many seconds. It's what works for you and what matches all the rest of your fingers. All right, nails. Simple, done, over. Let's move on. Now we're looking into sudoriferous glands, or sweat glands. If you're wondering, why do I have 4 different names up here for sweat glands? That's because all 4 of these are derived from the same type of gland. The eccrine sweat gland, the apocrine sweat gland, those are traditional sweat glands. But ceruminous and mammary, they're not really sweat glands, but they're derived from sweat glands. Let's start with the eccrine, or known as the merocrine sweat glands. These eccrine sweat glands, you can see here's one right here. The eccrine sweat glands are going to be differentiated because 1, they're all over the body, but 2, they open onto the skin surface. So they have a direct opening. They don't need anything else. That's a distinguishing feature of the eccrine sweat glands. Now they're simple tubule, so 1 single coiled tube going through. They secrete sweat. Their purpose, cool the body. These eccrine sweat glands. But now compare these eccrine sweat glands to the apocrine sweat glands. Here's an apocrine one. Notice how the apocrine sweat gland is going to go up to the actual hair follicle. That's one of the distinguishing features there. Apocrine sweat glands have to open into a hair follicle, and then its secretion goes up to the cell surface, up to the surface of the skin. Now these are found in the axillary region and the anogenital region. So anogenital, genitalia, but think axillary is armpit. Remember back to chapter 1. So they're more specific to these 2 locations. They're still the simple tubule coiled glands, but their secretions are thicker. It's a thicker, more lipid-based sweat in this case. So this is an increased lipid content, which makes it thicker, more of a milky solution almost, that's only found in the axillary and anogenital regions. Now, from some research, they're also saying these have something to do with pheromones, but they're not really exactly sure how pheromones play a part in humans necessarily. That's still an ongoing research. But they know that they play a part in these particular glands, in these apocrine glands. So we have the eccrine and the apocrine sweat glands. Ceruminous glands. Now, ceruminous glands, external ear. So basically, they're in the actual ear canal, the ceruminous glands. They're producing cerumen, or known as earwax. So what's the purpose? Why do you have them? Well, first of all, you're trying to get rid of insects. Nobody wants insects in your ear. Secondly, blocking entry of foreign material. Well, why do you want to block entry? Because you don't want things getting lodged in your ear. So if there's debris in the air, it won't just get stuck in there. You then also have the aspect of making the eardrum pliable, or keeping it pliable. This is important because as you go into the eardrum itself is a membrane that covers the channel. That membrane is how you hear sound. It receives vibrations and transfers those along. If it's not pliable enough, it can tear or rupture. So it's important to keep it pliable. Waterproofing. I'm sure you probably had water get in your ears at some point. But normally water doesn't really hang out in the ear, doesn't stay there. Because the cerumen is a lipid component, which means it doesn't really mix with water. So for the most part, it tries to create a waterproof covering of the ear. So water is not going to stick around or get into problems there. Now sure, sometimes water gets trapped, but for the most part, it's a pretty good waterproofing of the ear. And the last one is bacteria. You don't want bacteria growing in your ear canal. So this cerumen is going to help to get rid of or keep bacteria from growing in the first place. So it's killing off bacteria to get it out of your ear. Keep the ear pliable, keep the ear functional. So the ceruminous gland, producing cerumen, is going to be a derivative of the sweat glands. Then mention the mammary glands. Mammary glands, secretion of milk, nourishment of infants. I'm sure we have an idea what those are. But how does it all work? The original sweat glands produce the sweat. But this modified variation now is not producing just the pure lipid basis like the cerumen and the earwax, but it's producing a lipid-heavy, nutrient-rich solution. So all these individual glands in here Their label here is alveoli. Those are the modified mammary glands. And those modified glands are what produce the milk that will nourish the infant. All derivative and based off of the initial sweat glands. So the mammary glands, in this case, producing milk. All right, from sweat glands to the sebaceous glands, or the oil glands. These sebaceous glands, you can see one right here. Those sebaceous glands are producing sebum. Sebum is oil, basically. What's going to happen here is these are simple branched alveolar glands. Simple branched meaning they're coming off in different ways. Alveolar, rounded. But they're found throughout the body, but they secrete directly into the hair follicle. They can't go to the skin surface. So they have to secrete into the hair follicle. The sebum then goes up the hair follicle to the surface of the skin. So it's utilizing the hair follicle to get the sebum onto the skin surface. So here in this micrograph, this is going to be a sebaceous oil gland. What you're seeing is all the individual cells in there, and this is the sebum right here that's going into this hair follicle, which is this long strand, it's the hair follicle. So it's allowing the sebum to leave into the hair follicle. And this is occurring through holocrine secretion. So really what it means is cell fragments, pieces of the cell are being broken off. And those are lipid-heavy pieces. So there are a lot of lipids in these fragments. And that's simply secreted out through the hair follicle. Helps with the hair to lubricate and soften the hair, but it also goes onto the surface of the skin. That surface of the skin helps with, again, also softening the skin, but helps with deterring bacteria as well. Helps with slowing some water loss because it's lipid heavy. So we kept talking about more and more of things getting in, but don't forget, you need to keep the fluids in your body. Keep what you have and prevent it from getting out. So this sebum, this oil, coats the skin and helps slow down evaporation of water through the skin. Now if you're saying, well, hold on, sweating is water. True. But in that case, the sweat glands open up directly, and that's an easy pathway of water on the skin surface. These are covering up the cells to prevent the slow leaking of fluid out of the cells themselves. Mentioned before, it's bactericidal, so it helps prevent bacterial growth, or at least the bacteria we don't want on our skin, because obviously we have some bacteria we do want on our skin. So a little bit about more of the skin, looking at different glands, from the sweat glands to the oil glands, and going on from that aspect. So the skin really has a lot of different things going on, a lot of accessory structures and growth occurring in it. So all about the skin.